Hi, this is Mr. Goma. In this video, we're going to answer the question, what breaks when stuff boils and why? Now, vaporizes is just another word for boils. So let's take a look at water. If we had a pot of water and we could zoom in to the supramolecular scale, we might see something like this. We'd have lots of different water molecules, O and two H's, H2O, held together by covalent bonds, and then each of the separate water molecules held together by intermolecular forces. So we could label them, as I did here. The solid black line is a covalent bond. That's what holds together a single water molecule. And the IMFs, in this case, they're hydrogen bonds between water molecules. The IMFs hold together separate water molecules. So if we were to add some energy, like a flame here, we might cause this pot of water to cause the water molecules to go into the gas phase. So the question is, would the water molecules go into the gas phase looking like this, or would they go into the gas phase and separate out like this? What's going to happen? So let's make an analogy and think about two things here, a steel chain and a strip of paper. And the question is, if we were pulling on these here, what would break first? Well, obviously, the steel chain is stronger and the piece of paper is going to be weaker. So if we were pulling on these things here, the steel chain would break last. It's much stronger. And the strip of paper would break first because it's weaker. So if we're pulling on these things. So if we had to make an analogy, is the covalent bond more like the steel chain or more like the strip of paper? Well, covalent bonds are much more like the steel chain. They're very strong. And IMFs are much more like the strip of paper. They're much weaker. In fact, hydrogen bonding, which is the strongest IMF, is only 5% the strength of a covalent bond. So IMFs, much weaker than covalent bonds, just like a strip of paper, much weaker than a steel chain. So if we're pulling on them, what's going to break first? Well, compared to here, these two, the strip of paper would break first, and these two here, what would break first? Well, the IMF will break first. So let's go back to our water here. So again, what would happen here? If we're adding heat, what's going to happen is that these IMFs are going to break first because the IMFs are much weaker than the covalent bonds. So our water molecule would stay together as a molecule when it goes into the gas phase, but this IMF would break because it's much weaker than the covalent bond. All right. So in fact, it takes only 100 degrees Celsius to break an intermolecular force. That's the temperature in Celsius at which water boils. So which we go from liquid water to water in the gas phase. Whereas it would take something like 3,000 degrees Celsius to break the covalent bonds that hold together a single water molecule. Now, where would you find 3,000 degrees Celsius? You'd have to go to the surface of the sun or the inner core of the earth. That's how hot it would be. It's so much hotter. It takes so much more energy to break these covalent bonds. So to answer our question here, what breaks when stuff boils and why? Well, the answer is that the IMFs break before the covalent bonds because they are weaker attractions than the covalent bonds. I hope this helped.